Hi, good morning, Math 2. Happy rainy Monday morning for you. So I'm absolutely certain, because I know you guys, you crazy, crazy cats, that over the weekend you didn't have any homework, and I'm 100% certain we're going to need a quick little logarithms warm up. Okay, so the first thing I want you to do is take care of these, evaluate these logarithmic expressions, please. A and B, right, are pretty straightforward. I'm just going to make sure that I'll do one with you here. Maybe you're someone who is like, oh, log base 2 of 8. That means what is the exponent that 2 is raised to give you 8? And sometimes some of you may be able to say, oh, it's equal to 3. Maybe you're someone who's like, oh, I'm still waking up and I forget all of this. And what I said before was, maybe you can say, all right, I'm going to call this equal to x. And then I'm going to rewrite this exponentially. Let's see, 2 to the x equals 8. That means x equals 3. Okay. And then I get down here for some interesting things. Okay. Maybe let's look at G. Maybe you can see that, oh, the exponent, the 25, has to be raised to give me 5. What is that again? Well, I know the square root of 25 is 5. That means this equals 1/2. But maybe you are still foggy. I'm going to do this. And I'm going to rewrite this exponentially. 25 to the x equals 5. 25, the square root of 25 equals 5. That means x equals 1/2. Okay, go ahead and just evaluate these and then replay me for the answer, please. Okay, these are the values there. Okay, and I also want to just do a little recap here of properties of logarithms. So we talked about these several times, and you did some work with them. And I'm just going to write them down right here. But this is saying log base 10 of a times b, right? Unwritten, but understood the base is here. Log base 10 of a times b equals log base 10 of a plus log base 10 of b. Log base 10 of a over b equals log base 10 of a. Okay, you can read this. This is particularly important. This is log base 10 of, and what's in the parenthesis here is log base 10 of some number a raised to the power of r. This is the swing in front property, right? That number r can come up front. What I want you to do is look at number 514 for a refresher on how you used these, okay? 514 is the one that I had worked with you, I think, on one example, and then I gave the rest of you for homework, okay? And then a little bit of a recall on solving exponential equations. And let's just remember these. When you're solving exponential equations, we had varying levels of difficulty. And remember, again, these are both exponential equations because the variable you're solving for is in the exponent. And the kind of JV version of this was, we said, oh, okay, I'm solving this exponential equation, and I noticed that 4 and 16 share a common base, right, of 4, because 4 raised to the first is just 4, and 4 raised to the second is 16. And what we did here was we would rewrite both sides to the common base. Well, 4 is all done. And then 16 is just 4 squared, right? But this cubed is still out there. And you'll recall what we did here was, and we just kind of cleaned up my exponents. Power to a power, we multiply. 4 to the blah equals 4 to the blah. Once we have a common base, we know that then the exponents must be equal, and x equals 8. Okay, a little refresher. And then we got into this world. It's like, oh man, what if you have an exponential equation where, for example, 1.02 and 3 do not share a same base? And what we did back then was, what did we do? Do you remember? We rewrote these, right? Okay. We rewrote and expressed both 1.2 and 3 as a power, as 10 raised to the power, as a power, as 10 raised to an exponent. And you'll remember when we did this, we kind of went over here and did side work, and we said, okay, how can we write 1.02 as some power of 10. How could we do that? And we said, oh, we can rewrite this equation logarithmically. So the log base 10 of 1.02, right? The exponent that 10 is raised to give you 1.02 equals what? And that was a calculator, I think. Didn't we use a calculator on that? Yeah, we totally did. And now I'm going to have to go use that. I think we got 0.0086, right? So then we said, okay, well, let's rewrite 1.02 as, okay, so this becomes 10 to the 0.086 because this number is now 1.02. Oh, raised to the power of x, can't forget that, okay? Equals, and then we said, okay, well, let's figure out what 3 is, right? What is 3? Okay, that's the side work. 3 is 10 raised to what power? And then again, we rewrote this logarithmically. So we did log base 10 of 3 equals x, and this equals, I go over here and do it. I'm getting 0.4771, right? 0.4771. So that means 3 is 10 to the 0.4771. And then I'm going to take care of my exponents by properties of exponents. So we went from JV and then went to varsity. The varsity version of this is, right, without a calculator, okay, there is no common base. We kind of created the common base of 10. In part A, we see a common base of 4. Okay, part B, we had to create the common base of 10. And then, of course, we get down here, 0.086x equals 0.477. And when you take care of this, we divide. And oops, I'm going to let you kind of do that because I'm not right in this moment. My calculator just walked away. You're going to get some value for x. Okay, so that then leads us to our lesson for today, which is, let's see, if this is kind of like the JV version of exponential equations, maybe this is the varsity version. I'm going to call this varsity version A, right? Because what I'm really showing you is another method for solving equations where you cannot see without a calculator what a common base is, and you have to kind of create a common base of 10. So I'm calling this varsity version A, and here's varsity version B. And let's just stick with that exact same equation. So this is the new stuff now, okay? So another way to solve exponential equations . Okay, all right, so this is new for us. And I'm going to start with that one. Okay, so let's say we're told to solve 1.02 to the x equals 3. All right, and here's where, when I go about solving this, I absolutely know some of you are going to say, wait a second. These two look very similar. It's just a different way of framing it. And yeah, you are absolutely right. Okay, so everyone, here's what we're going to do. I'm going to tell you that, in our journey of solving equations, general equations, the cardinal, the golden rule, if you will, the golden rule of solving equations is that you can do whatever you want to the equation as long as you do it to both sides. Okay, you can do whatever you want to equation as long as you do it to both sides. Well, here is yet a new thing that we can do to both sides of the equation. We are now going to take the common logarithm of both sides of this equation. Okay, and I'm specifying common logarithm because the base is 10. So this is something new for us. We've never done this before. Okay, I'm going to take the log base 10 of both sides. Up until now, we've square rooted both sides, we've added 7 to both sides, we divided both sides by -3, we've, we can do anything we want to an equation as long as we do it to both sides. So why don't you follow along with me here and let's see what happens. I'm going to take the log base 10 of the left-hand side of the equation. I'll fill it in a second. And I'm going to take the log base 10 of the whole right-hand side of the equation. I'm just using those brackets just for emphasis. And let's see. Log base 10 of the left-hand side of the equation. Log base 10 of the right-hand side of the equation. And I think Dylan and I forget who else was asking me this. You guys were like itching like last week, like, what's the shortcut, Miss Yam? What's the shortcut, Miss Yam? And I'm like, I don't know. I'm like, right? I was kind of being very vague and kind of avoiding your question, right? And you're like, well, what's the big whoopee here? Well, the big whoopee, something looks very familiar. Let me scroll. Oh, my stars and stripes. Take a look at this property of logarithms. It says if you're taking the logarithm of something, that a, and that a is being raised to the power of r, that r can swing out front. My stars and stripes galore. If I'm taking the logarithm, base 10, of something raised to the power, that power can swing out front. So, by properties of logs, this left-hand side becomes x times log base 10 of 1.02. And this equals log base 10 of 3. And here's where I'm going to start being really deliberate about this. When you take a logarithm of something, generally speaking, you see how I have parentheses here, and I think sometimes if I'm not thinking, like I just kind of breeze through and I'll forget like to parenthesize that which I'm taking the log of. Notice my language. It's log base 7 of 1, log base 16 of 4, log base 6 of, okay? So I just am in the habit, and I want you to be in the habit too, of just parenthesizing that which you're taking the log of. Now, what is the operation right here? Oh, right, it's times. So now, folks, how do we solve for x? Yes, we divide both sides by log of 1.02 all over log of 1.02. And at the end of the day, what do we get? We get x equals log of 3 over log of 1.02. Ladies and gentlemen, do not make the catastrophic, terrible mistake of confusing this expression with the property of log. I cannot tell you the number of times people will say, oh, this just equals log 3 minus log of 1.02. No. That property works this property applies if you're taking the log of a minus b, that the of part is a over b, right? It's not log of a over log of b, which is right here. So you're wondering, oh, Miss Yam, then how do I get my decimal answer? Well, if you had a calculator, you would just calculate log of 3, and luckily we did it up here. Log of 3 is what? What's log of 3 again? 0.47, yeah. So with a calculator, you would go over here and say 0.4771 all over 0.086, and then you'd kind of finish that calculation. But guess what? Without a calculator, if this was a non-calculator active question, this is your final answer. So when you look at these two, hopefully you're going to see some connections here between varsity version A and varsity version B. And I hope you see some steps where it's like, oh, we're just doing the exact same thing in less steps. True. The other thing that this allows you to do here, everyone, is it allows you to solve an exponential equation, one where there is no shared base. It allows you to solve it without a calculator. Oh my stars. So let's do another one, shall we? Let's solve. I'm gonna give you a couple of equations to solve. Go ahead and let's solve the following for x. Okay, let's see. All right, let's the first one. Let's do exponential equations, right? Exponential equations. You want to go big or go home? Let's just go medium or go home first, okay? Let's just take care of that. All right, 5 to the 2x minus 1 equals 11. And here, I'm going to solve without, I don't want you to use calculator, without a calc, which means you leave your answer in exact form, which is like that in the case above, okay? And here's B. Let's see, let's do, okay, I'm kind of liking this. I like it. Oh, yes, let's go, not quite super size, but let's go medium size, like the value meal, okay, the value meal. Let's just go crazy. Yeah, I like that. Okay, well, let's do the first one together in the new way. And let's see, I'm going to take the logarithm of base 10, or take the common logarithm of both sides. So now I'm going to take the log base 10 of, and again, I'm in the habit of parenthesizing that which I'm taking the log of. It just makes it mentally clear for you. And then you're saying, oh, I've got the swing in front property because it's the log of 5 raised to the of portion is being raised to the. So yay, that means 2x minus 1 can swing in front, and that is multiplied by, so watch our parentheses. Parentheses are really important right here. And this equals log 11, base 10 of 11. Okay, and I'm solving for x. Ooh, this is a little bit groovy. I have to divide both sides by log 5 first. Okay, and so I'm going to divide log base 10 of 11 divided by log base 10 of 5. Oh, but I have to solve for x. Yes, and right, and this is just same thing as just 2x minus 1, right? Now that I've kind of divided by the factor of the parentheses, I don't need any more. What do I do? Well, now we're in old school land. We're in old school. So we're going to add 1 to both sides. So 2x equals old school. Log base 10 of 11 over log base 10 of 5 plus 1, right? And then I'm going to divide by 2. And I'm not going to get freaked out by the fact that, without a calculator, plus 1. What's being divided by 2, everyone? Yes, this whole thing. And yes, I want you to leave it like that, okay? Now, you all go yonder here and try this one on your own, then replay me for the answers. Okay, let's see what you did here. So you took log base 10 of both sides, and here I just kind of changed my color to make it very clear that this power of 3x plus 2 is to the 2/3. I swung it out in front, the swing in front property, divided both sides by log of 2/3, subtracted 2. Look how I'm making really clear to the reader. It's all of this minus 2, right? The fraction bar does not extend over here. Then divide all of that by 3, okay? All right, so here's what's really important. I want you to listen very carefully. I'm gonna put your homework on the teacher page, and you're gonna notice that I have listed the problems in a specific order, okay? Do the problems in that order. I know they're gonna be like out of order, so to speak, numerically, but I want you to do the problems in that order. A couple of things. Just so you're aware, don't freak out. You have, I think, 2 questions that refer to this new idea here. You have a question that's a blast from the recent past. It's going to be a whole lot like 514, so you can refer back to that. And I'm talking about question number 529 is basically just like 514, okay? You've got a little blast from the past of an exponential function with some playing around with it. And then the very last question is 530, okay? And that is you taking an equation and rewriting it maybe logarithmically. You may want to think about, just try it. You may think about rewriting them logarithmically or exponentially, or maybe you're just doing regular old algebra. So number 530 is kind of playing around a little bit. Like that's kind of a pure problem solving question. So if you get to 530 and you're like, I'm just gonna try my best, that is okay. All right, everyone, have a wonderful day. And again, please do the questions in the order I specify. Goodbye.